Hello, everybody, and welcome to to the last Mystery Box Function Challenge. This is the 365th Mystery Box Function Challenge. A year ago, I made a promise to myself that I would do one of these every single day for a whole year, and here we are a year later, and this is it. So this is a particularly tough one. Inside the purple mystery box, there's some math, some tough math, and your challenge is to figure out what that math is. As always, you can use the link in the description to try this out on your own. And when you've got an idea, come on back and see if we get the same thing. All right, let's start with a 0. All right, 0 gives us 0. How about a 1? 1 gives us 1. How about a 2? All right, 2, we're already off the graph with 16. How about a 3? Oh, my goodness. Okay. So what is that? Million, billion. Looks like 7 trillion, almost 8 trillion. So 3 gives us somewhere 7 trillion and something. So that is a pretty quickly accelerating curve. Let's look in the negatives. How about a -1? It gives us a -1. How about a -2? So that's not a number. How about a -3? Interesting. Okay, so we've got a couple of things going on. We've got a quickly accelerating curve, like super quick accelerating curve. That immediately makes me think exponential, so something to the x. And actually, we saw with x to the x some problems with the negative numbers. There were lots of undefined values over on the left side of the graph for taking square roots of negative numbers. So maybe we got something to do with that going on here. I actually want to see this curve a little bit better. So I'm going to put in some values between 0 and 2 here. So let's put in, let's say a 1/4 and a 1/2. Okay, so you can start to see the shape of that curve. I'm going to guess that -1/2 is undefined as well, but let's see. Yeah, so that makes sense to me. Let's try 3/2. Okay, and let's try maybe 2.6. Oh, and that's already way, whoops, 2.6. I meant 1.6. Okay, and how about 1.7? And maybe 1.8. Okay, so I think we've got a good sense of the shape. There's weirdness going on the left side. Maybe there are some defined points and some undefined points here. So the graph is not going to be continuous over on the left-hand side. On the right, we've got this rather shallow curve to begin with, and then at 1, it really starts to accelerate up super, super fast. And between 2 and 3, it goes from 16 to 7 trillion. So what could this be? Well, I'm definitely thinking exponential still. So let's think about what could give us a 1 at 1 and a 2 at 16. So if it's something to do with x to the x, 2 to the 2 would be 4. I guess if we multiplied this by 2, that would be 2 to the 4th. That would be 16. So, oh, but that wouldn't work with 1. If we did 1, well, actually it would. 1 to the 2 times 1. Would that work with 3? 3 to the 2 times 3. Well, 2 times 3 would be 6. 3 to the 6th is not 7 trillion. Oh, so this is not 2 times 2. 2 squared is also 4. So what if we did 2 to the 2 to the 2? Oh, okay. So that would work with 1. So what if this is x to the x to the x? So 1 to the 1 to the 1. 1 to the first power is 1, and 1 to the 1 power is 1. That makes sense. I don't know about this 0 result for 0, 0 to the 0 to the 0. Is that 0? I don't really know. I bet there's some disagreement about that. But 2 to the 2 to the 2. 2 to the 2 is 4. 2 to the 4th is 16. How about 3 to the 3 to the 3? Could that be 7 trillion? So 3 to the 3 is 27. So 3 to the 27th power. Yeah, actually, that could be 7 trillion. That actually makes good sense. I don't know if there's a whole lot of other points we can test here. Well, how about that -1? So -1 to the -1 to the -1. Well, what's -1 to the -1 power? Well, that's just 1 over -1, so that's -1. And then what's then -1 to that power? Well, it's going to be -1 again. So that makes sense that -1 would come out as -1. I think we may have this very strange looking function, but x to the x to the x. Let's go ahead and take a look. Yeah, x to the x to the x, and let's graph that. You get that rather gentle curve between 0 and 1, and then accelerating super fast after that. And then it doesn't even graph the left-hand side, all of the negative values, because there are so many undefined pieces here. This graph is just not continuous there. Well, how did that go? That's super tough. Were you at least thinking exponential? I'm sure you were, but let me know. And thank you for being here. And for those of you who've stuck with this series and followed through the whole year, thank you for being here with me. I really appreciate it and would love to hear your feedback. Well, that's all for me. Maybe there'll be a different series coming up someday soon, but for right now, I'm taking a little break. Thanks, everybody.